hope to show you some simple ideas, some of my thoughts on how to use the distance formula and the midpoint formulas. They look really complicated and ugly. Here's the midpoint formula. Midpoint formula looks like this. M, the midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, and so on. Okay? It looks really nasty that all these x1s and x2s that uses subscripts and stuff, and you can use the formula just the way it's written and plug things in, but it helps to understand what's going on and why it's doing what it's doing. The key is recognizing what the formula is doing. This is taking an average. An average. You recall how to find an average. So if I gave you three numbers, 5, 7, 11, and asked you to find the average, you'd add them up. 5 plus 7 plus 11 and divide by 3, right? And I'm not going to worry about the arithmetic. It's going to come out probably 18. Well, 18 plus 5 is 23. Yeah, it's not going to come out even. It's about 7.7 or so, something like that. But add them up and divide by how many there are. In this case, it's the average of the x-coordinates and the average of the y's. So you're just adding the x-coordinates and dividing by 2, and you're adding the y-coordinates dividing by 2. And the cool thing is, it really doesn't even matter what order. x1 plus x2 is the same as x2 plus x1. y1 plus y2 is the same as y2 plus y1. Just remember to put the x first and the y second. So in this particular case, A is 4, 2, and B is -1, -3. I'm going to add. So the midpoint is 4 plus -1, which is 4 minus 1, divided by 2. And 2 plus -3, or 2 minus 3, divided by 2. Do the arithmetic. And M is, I'm going to continue it on to the right here. M is 4 minus 1, or 3 halves. Or 2 minus 3, -1 half. Okay, I could express that as mixed numbers. I could express that as a decimal. It's 1.5 and -0.5. And let's go see if that's accurate here on our graph. So 1.5 and -1 half is right here. So yeah, lo and behold, the midpoint, it appears to be right in the middle. Right in the middle. So that's the midpoint. Okay, average of the x's, average of the y's. Add the x coordinates, divide by 2. Add the y coordinates, divide by 2. All right. The distance formula also looks kind of ugly, right? The distance formula between any 2 points is x2 minus y2 squared plus, I'm sorry, x2 minus x1 squared plus y2 minus y1 squared, square root. Now the cool thing about the distance formula, just like in the midpoint formula where the order doesn't matter, the order actually doesn't matter in the x's and the y's here on the distance formula as well, because all we're considering is how far apart things are. Let me show you a quick example here. Let's say I do this particular one. x2 is, I'm going to call this x2 and this x1. So I'm going to say 4 minus -1. And then I'm going to square it. I want to show you that order doesn't matter, because if I did it -1 minus 4, I get the same answer. 4 minus -1 is 4 plus 1, and 4 plus 1 is 5. 5 squared is 25. -1 and -4 is -5. -5 squared is -5 times -5, and a negative times a negative is a positive. You get 25 no matter which one you do. Okay, so don't worry about the order. That's really kind of an important little trick. You don't really have to worry about the order when you subtract. It's really how far apart the numbers are. So here's one way I think of it, and hopefully this will help make sense to you. And this is just kind of the weird way my brain works, but maybe it'll appeal to you. Okay, I'm going to write these coordinates down, and I'm going to note how far apart these numbers are. Think about it. How far apart are 4 and -1? 4 and negative 1. Well, to get from 4 to negative 1, I'd have to go through 0. 4 to 0 is 4. Then I'd have to go from 0 to negative 1, so that is a total distance of 5. So 4 and negative 1 on the number line are 5 apart. Let me demonstrate really quick. Here's negative 1, here's 0, 1, 2, 3, 4. If you count the spaces, there are 5. 1, 2, 3, 4, 5. Okay? So how far apart? You're answering it's distance. It's how far apart things are. So how far apart are the x's? How far apart are the y's? From 2 to negative 3 is also 5, right? Or negative 3 to 2. It doesn't matter direction. The distance is 5. So the distance formula says the distance is the distance between the x's, 5 squared, plus the distance between the y's, 5 squared, square root. That's really kind of cool that way. You can kind of bypass the step of direct substitution, having to know all the subscripts and stuff. It's the distance between the x's squared, the distance between the y squared, added and square rooted. So let's finish this. 5 squared is 25. 5 squared is 25. Okay, 25 and 25 is 50. Okay. And here we get into a little bit of a discussion about something called reducing or simplifying radical expressions. Okay, it may be of note that 50 is 2 times 5 times 5. And so this is the same as the square root of 2 times 5 times 5. There's a pair of 5's in here. The square root of a number times itself is just itself. The square root of 5 times 5 is 5, right? And so this pair of 5's comes out as a single 5. We end up with 5 root 2. Now that's if you're asked to give an exact answer. If you're asked to give an approximate answer, just pull up your Desmos calculator. Let me go desmos.com. Okay, I'm just going to type desmos.com in my search string here. And choose graphing calculator. There we go. Okay, and here's a little bit of a Desmos lesson. Type SQRT, and when you hit the T, SQRT, the square root symbol will appear. You don't have to use the show keyboard option. You can. It is there. It's right down there. Okay, but square root, SQRT, of 50. Not 509. And it's about 7.1 to the nearest tenth. 7.1. Notice, by the way, I use a wavy equal sign. That means approximately equal to, that there was some rounding. Okay, and this is exact. These are equal because they are exactly the same. Okay, so distance formula. Midpoint formula, average the x's, average the y's. Distance formula, how far apart are the x's? Square that. How far apart are the y's? Square that, add square root. And hopefully that helps.